Welcome, B-Sidesers. This is programming loops in Splunk, and you can take that programming two ways. You can take it as building loops in Splunk, or you can take it as actual programming type loops in Splunk. Both are true, and you're going to see some cool stuff here. Let me tell you a little bit about me first. I'm Greg Woodcock, president of Splunkster. I've been Splunking since the 3.0 days, since 2006 or 7, somewhere around there. I used to be really big in answers. I'm in the top 10 for sure, probably top 5, maybe top 2 or 3. But we've been so busy helping you guys get your Splunk great that I just haven't had time to be active in answers very much. I'm all over community. I'm in Slack. You can catch me all of normal places you catch people. But enough about me. I'm basically the mad scientist of Splunkster. And I'm going to show you one of my craziest concoctions to date, which is how to do loops in Splunk. Now, this started out as a purely academic exercise, basically a challenge. Can it be done? And what we found was, more or less, yes, it can be done.
So the challenge that I took was just building an exponent function that says, take a base to an exponent and calculate 2 to the power of 10 in this case. So here I can see 2 to 10 is 1024. Exponent is take the base and multiply it by itself a certain number of times, in this case 10. So that's our first approach. This is what I would call an unwrapped or unrolled loop. This is not programming. This is not a loop. This is hard coding. It's not flexible. It's not extensible. It's not programmatical. But this is the starting point of the challenge. This is a functional piece of XML in a specific example. And then we're going to work towards getting an arbitrary base and power. That's the goal. So the next attempt is we'll create one command that can be exactly repeated a certain number of times. So this is truly an unwrapped loop. This exact SPL is repeated 10 times, and this is the loop that we would like to create so that these 10 lines are collapsed to 1, whether or not it's to the power of 10 or 20 or whatever, to the arbitrary number, in this case 10. And I'm going to show you step after step after step, an iterated approach. And there are going to be some blind alleys and teachable moments, but they're very useful because the purpose of the talk isn't necessarily to show you how to do loops. It's to show you how to use cool exploits of SPL to make it do things that maybe the designers never imagined it would be able to do. So the first thing we're going to do is we're going to exploit a peculiarity of the for each command. But before I show you the exploit, I'm going to show you a conventional use of the for each command. In this case, I've got 1, 2, 3, 4, 5 time date fields, and I'm saying for each time date whatever field, every field that starts with time date, create a human readable version of that same field formatted. And so now you can see time date now has a time date now readable, time date this month has another one, so on. This is an extremely conventional use of for each, which is a column-wise loop. For every column, this one and this one and this one and this one, for every column, do this same thing. And this field, this less than field, greater than, it's represented by this. So this will only happen, because I have a wildcard, this will only happen if I have some fields that match that. But I could lay out all of these one by one like this. Like this. And if I did this, it would work, and it would run this loop twice in this case, whether or not these fields existed. But with the wildcard, it'll only run if at least one existed. So we're moving on to where we have fields that don't exist. So these individual numbers, you notice I'm not using the less than field, greater than. I'm not referencing it. I'm not using a wildcard. So for each says, well, I don't care whether these fields exist or not. You told me for this one, and for this one, and for the 3, and for the 4, and for the 5, I'm going to do this thing for each one of those, whether or not the fields exist. And these could be anything. They could be A, B, C, D, E, F, G. So we're going to take this inner thing, and we're going to do it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see, because I don't reference any field names, it works. And you can see that we get the same thing we did in the beginning. So we have successfully created a looping construct for a hard-coded case. We've compacted these 10 lines into this one line. But there's a second level of compaction that needs to happen, which is we need to compact these into one command, because we might not always have 10. We're going to be using a variable called exponent equals 10, and we need it to create, maybe that exponent equals 20. We need to create a looping construct to collapse, constrict this looping variable into an arbitrary size. And to do that, we're going to use a very cool Splunk command called mvrange. And the way mvrange works, you give it a starting number and an ending number and an increment, which the increment defaults to 1. So this is ending number plus 1. I'm trying to go from 1 to 10, so I tell it arguments 1 and 11 and default to 1, and it gives me 1 to 10. And you see that in one command, I've grabbed all of my looping variables. For example, if I change this to 50, then it goes 1 to 50. And so 10 minutes into the talk, we've already collapsed 2 of our looping constructs, 2 of our design goals that are necessary to get where we're going. This looks like success, but look at how many tabs are left. We've got a long way to go, and these were easier challenges than what you're going to see. So just because we have this as a thing doesn't mean we can use it, because, for example, this is multi-value. So this is really still 10 things, and we need it to be one thing. So one way you can do that is you can use NoMV, and you can see it's now one thing. But the downside of NoMV is that if I get rid of this, NoMV replaces the things with new lines. So if you use NoMV, you'll have to convert it afterwards. But there's a better way. In most cases, when you do this, you want to join it with spaces. You can use mvjoin, and then you can tell mvjoin what joiner character to use. So in this case, I told it to use spaces, and voila! We now have exactly what we need for the Power 10 case. Now we need to put these two pieces together, and believe it or not, it's not as easy as it sounds. So to do this, we're going to use a sub-search. And some of you may not understand exactly what sub-searches do, so we'll cover that. Sub-search is a standalone search that's positioned in such a way that it runs before anything else in the search. And it generates a string that is then used by an outer search, which runs after it, and programs part of it. So sub-searches run in one of 3 ways. They return in one of 3 ways. If you don't do anything, what happens is it's implied that it's using format. And in our case, what would happen if this was a sub-search, it would do this. And that's not what we desire. So another way is I can do return just one thing like return I, and that will return just the one thing instead of everything it did before, and it's going to return I equals and I's value. But that also is not what I need. I need just the value. So the third way to terminate a subsearch is to return a dollar and then field name. And this will return just the value of I to the outer search. So that's your primer on subsearch. We're using the dollar one because we only need this. And if we try to merge them together, so in other words, we grab this and we also grab, we grab this whole thing and we backtrack to here and insert it here, what it looks like is this here. So I've pasted that subsearch here in where the for each, where this used to say 1 through 10, and it doesn't work. So what it didn't tell you about subsearches is what makes them subsearches is that they're enclosed in square brackets. But the unfortunate thing is that what makes a for each object is that it's enclosed in square brackets. So you can see the problem. I need for this to be treated as a subsearch, but because the syntactical separation of subsearch is the same as for each says, oh, this is my for each object, and let me consume that and run with that, and then it gets confused because it's actually not a for each. It starts with a generating search, which it shouldn't, and the whole thing breaks down. So this is our first brick wall. We were making such great progress, and now we're at a dead end. And much of this talk is going to be 2 steps forward and 1, 2, or 3 steps back. So we clearly can't use the subsearch method because of this syntax collision. So there are 2 ways to have one search program another search. The safe way is subsearches, which is why we started here. That's where an inner search programs an outer search. And the reason I say it's safe is because the inner search really can only make the outer search smaller. But you can turn this logic inside out, and the other option is to have an outer search program an inner search. And when you take that inside out design, that's done with map. But the dangerous thing here is that this outside search can cause this inside search to run so many times that it can cause your browser or your laptop or even Splunk itself to exhaust all RAM and crash. So we're taking precautions here with map. First of all, we're only generating 1 row. So map is a row-wise loop. It will iterate and do whatever's inside it for every row. And furthermore, we're ensuring that it only goes 1 time by limiting it with this max searches equals 1. So it only has 1 coming in, and it can only execute 1 if it has more than that. But if you do have more than 1 row, thousands, and you do something like 100,000, it's definitely not going to work. It's definitely going to crash something. It most likely will crash your search head or cause such resource exhaustion that things stop running for a while. And while this is not the kind of mistake that's going to get you fired, it absolutely is going to get you noticed and almost certainly get you yelled at. So don't just use map in your one use case and then just dump it into production without thinking really long and hard about how you're scaling it, how many events might be coming in it, and how you can protect it. And you might have a talk with your Splunk admin before you do it. So that's my warning about map. This is the exact same search as this one, except the inside is moved to the out and the outside is moved to the in. And you see that, hooray, our search runs. But what it doesn't do is do the correct thing. Why is that happening? So this actually used to work several versions of Splunk ago, but Splunk said, let's be helpful. If my field, in this case I, if this has spaces in it, which if you look at this, Does our I have spaces in it? It does. And Splunk says, oh, well, when we use this inside of a map, then I'm going to enclose the I in double quotes like this, essentially. And what this does is it takes our 10 things and turns them back into one thing, which is why our loop only runs once. So Splunk is going to do this behavior whether we like it or not. One way around this in general is to put a subsearch in here and return back a $I, and it will not have the double quotes surrounding it, but we already see this is a for each, and we can't put a subsearch here. But we have one other way to do this. We were going to go into macros anyway, but one of the interesting things about macros as a templatizing tool, just like map and for each are templatizing, they use these tokens. Map and for each will try and help you deal with your tokens, and they'll change them sometimes. But in the vast majority of cases where I do have values with spaces, I would like them treated as one value with double quotes. But we're in that edge cases where we don't desire that. And the nice thing about macros is they're dumb. They don't try and help you at all. They're brain dead dumb. They're stupid. And when a macro executes, wherever it finds $this, it's going to pass in whatever you gave it. In fact, if you pass in double quotes, it will remove them for you and just say, oh, well, he told me that, so I would know this is one argument. I'm going to remove those double quotes and dump it in. So simply by taking this solution, which runs but is broken because this gets double quotes, and translating it into a macro which does the exact same thing, it causes this to work. And here's another pro tip for you. I've never bothered to use input validation, so I hijack this error message as a comment field. So I always put description, say who wrote it, author equals Greg Woodcock, and any other details in here. So when somebody runs across it later and says, what in the world is going on here? Who did this monstrosity? They can say, oh, Greg did it, and read about what's going on. And another thing I do is when I list my inputs, or my outputs, my arguments, I label them. So these are inputs, so they have underscore input. If there was an output, I would have an output like this. Or perhaps I would have something that's both an input and an output. So now that we've put this code inside of a macro, this is the exact same call as this, but it's in a macro, and when I run it, I see that I get the answer. And if I do Shift-Control-E to have it unroll and expand my macro, it shows me that it put these numbers in here, which is actually what we did several tabs back. And this will actually run the same way if I put these double quotes in, because like I said, it strips them off to know that it's an argument, you know, because if I had put commas in there, it would need it. But anyway, it moves. So now we've got a functioning proof of concept. So what's next? You notice that here we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's not what we're actually going to pass in here. We would like to pass in that thing that generates 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we grab this code and we come back over here and we paste that as the second argument here, and then you try to run it, it doesn't work. So why doesn't it work? Well, like I said, the macros are dumb. So the macro does not allow the subsearch to get executed first because the macro substitution happens before the subsearch substitution, and that's so that you can have macros inside of subsearches. So you can't have subsearches inside of macros if you need macros inside of subsearches. So It won't work because of the order of operations by the SPL parser. And once again, we've hit a bit of a dead end here. So we can kind of double down, and we can still use this macro, maybe, by passing in, by constructing the I on the outside and passing it in. Because remember, we already said back here, I can pass in double quotes here, and the macro will say, oh, those double quotes are telling me it's an argument, and so let's do that. So we're going to flip it backwards again. Instead of going inside out, let's go outside in. The second case of what we did a couple of tabs back. And you see that it indeed works. So now let's take this exact stuff, package it up again, and stuff it into a second macro. And now I'm passing in an actual 10 instead of 1 through 10, and it works. We've got 1024. It works, and I can do, a different number. And now we have a functional proof of concept. But look at how many tabs are left. We got a lot more work to do and a lot more trouble. And the problem we have here is we'd like to have some set of results, like in this case, just one, and we'd like to run our thing based on those results, and it says, hey, I can't deal with that. This has to be the first line of a search. The make results that's in here, and it's not. So what are we going to do? Well, let's do something a little different, and let's put it into yet another macro. And if you look inside here, what I'm going to do is I'm going to put this in as a subsearch, exactly what we did in here. So we're going to talk about another programming construct here, polymorphism, or input overload, or I think it's input argument overloading. But anyway, notice that I have pow by values 3, and this version has 2 arguments. So I'm using the same name for 2 different macros, and this allows me to have a smaller, less complicated one that defaults with a hard-coded default value. So this one allows you to pass in base, field name, output field name, base, and power, whereas this one just gives you the output field name and the base, assuming a power of 10. So what's in the 3-argument version that's going to allow us to get around this problem? So in this case, we've told they passed in an output name, so we're going to create that one, and we're going to return the answer, right, by using essentially the same thing we did several tabs back. So if we try this with 2 different examples, you can see that again it works. So we've gone around the block another time. So we have 1 row, and then we have 2 function calls, different, and we have 2 different variable names. So there you go. This works. And again, I can put a 10 in here, or I can remove this 10. There. Now, oh, I forgot the parentheses. Now you see a 2-argument call and a 3-argument call, and this one calls that one. And you can see that it works. It does everything we need to do, but there's one further step that's left, and it is the hardest thing of all. This last thing is to convert these hard-coded numbers into variable names like we started out. Remember in the very beginning where we had a thing called base? Well, if we try to do that, where did I end up here? Yeah, so let's go ahead and try it. Let's create a base called 2 and a power of 10. Let's pass it in, and we see that it doesn't work. And it doesn't work in such a bad way that Splunk won't even run it. Like it's just like, I don't know what you're saying. Doesn't make any sense. So let's see if we can get partway there. Let's keep the 2 and hard code the 2 and pass in with power. Does that work? And indeed has the same exact problem. And let's try the next one. Let's put the 10 in as a hard coded and the base, and we get another error, a different error, but it's still an error, and it's not going to work. So we're at a total brick wall. We don't even have a piece of the previous thing that we can use, and we may have to back up quite a bit. So when you ask what's wrong with this, if I do Shift Control E again, oh, I can't do it from here. Oh, it's not going to show me here either. So if I go back and look what this macro is doing, when I pass in base, which is here, you'll notice that it's inside of a sub search. And remember, I told you that sub searches run first. And from here down to here, there are no fields because it threw away the only field that exists. Now it's going to create a field called I, and it's based on a field name. We're passing in a name called power. Well, there is no field called power here, right? If I pass in a 10, if it's a number, it's just going to drop the number in, and 10 plus 1 is a number. Numbers are contextless. 10 is just a 10. You don't need any information other than just the name of it. It's a number. But if it's a field name called TEN, and maybe the value is 10, or maybe the value is 1,000,000, or maybe the value is not even a number, it's foo. Well, now you need a context. You need that field to exist to see what its value is. And in this case, because of the make results in a sub search, that field does not exist. So this is completely broken, and we need to start a good bit over, because what we need to do if we're going to use anything like this is we need to pass a value, a field name, through this sub search barrier, or from one part of a search to another search. So let's look at some ways that might have worked. So one way to do it is to encode the information in a field name, because we know that for each allows us to pass a field name in through this field variable. So if I create a field called pow by values input to 10, which is what this does. So if I look at this, that's what it does. That's what these curly brace things do. In this matching here, not only is field created, but match seg1 matches the first wildcard, and match seg2 matches the second wildcard. And because of this curly brace thing, if you put a field name in a curly brace on the left side of an equal sign in an eval, it will take the field name, the value of base, and put that value in here, right? I kind of glossed over that, but that's what it's doing. And now when I pass this field name in, it actually creates a field based on this. I have to run it again. And it really doesn't matter what's in here. This actually could be, it could be foo, right? It doesn't matter. It just needs to exist, because we're not using the value. We're using the name. So by passing it in, I'm able to encode values into a name, pass the name in, and then decode the values back out of the name. So this does work. You can see that 10 times 2 is or 10 plus 2, I put a plus, it works. So let's see if we can take this approach and use it with our stuff. So I had some high hopes here, but you can see that it doesn't work. And it's giving the same kind of errors before, because if the order of operations had allowed the for each to go in first, it would have worked. But what it does, if you have for each and a macro together, the macro gets resolved first. And so that means that instead of getting a base value of 2 here, what gets passed into the macro is less than, match seg1, greater than, which is utter nonsense. And, you know, we were happening that this would actually be a 2, and this would be a 10, and everything would be golden. But that's not what happens, and there's nothing we can do about it. Even if it was programmable, you wouldn't change the order of operations. But I'm not beating this dead horse just yet, because I'd like you to show you some more trickiness with this kind of idea. Let's just make sure, and let's put the 2 in there hard-coded and see if that works, and it doesn't. If I put the 10 in, I get the same error, and if I put both of them in, it works. And the reason that it works is because field underscore resolved goes into the macro, and field underscore resolved comes back out, and then is passed to for each because this ran first, and it just gives it the appropriate name, because what we really needed in the macro was this and this. So this went into the macro, came back out of the macro, for each changed it. It was great. But anyway, this won't work. But let's look at other ways we might approach this. This tells us that for sure POW by values runs first, the macro runs first. But maybe we can encode the actual macro call, not the macro arguments. So let's see if we create a field name with the entire macro name in it. So you can do this with creating it, you know, with commas, and you can do this. So let me just rephrase that a little bit. I could do this by doing this, and probably I should, because it'll be less complicated. Let's just grab it. It's this. So I can say this there we go. Now I put my function call in a field name. And if I take something like this and I try and pass it in like this, but again, it's not going to work, because remember, macro evaluation happens first. So even though we've prevented the macro evaluation from going too soon, we've missed the window. It's not like it happens at the beginning and it happens at the end. So we've missed the window and it fails. So let's try one more thing. It surely won't work. Let's get rid of the graves and just pass in this case, pass in the macro name into the graves. And it has the very predictable response that it says, hey, I don't have a macro called less than field greater than. And so really this is a total disaster of a dead end. So we're going to have to backtrack quite a bit to resolve the fundamental problem, which is that our macro that we're using, where is it? Way back here. It's making use of a map. And what map does is it consumes your rows as it processes them and swaps them out for answers. It's kind of like stats. Stats will consume all of your rows and give you the answer. In that way, map is exactly like stats. They both consume the rows and return the results from the details provided to them. And it always throws the incoming rows and details away. So in stats, if this was stats, I would say, hey, no problem. There's event stats. Event stats does the stats, dumps the results out in the original details, and I have both. And if Splunk had provided a command called event map, then we'd be done. We would just call event map instead of map, case closed. But they don't have anything like that. So what we're going to try to do is figure out a different way to unwrap it and take a fresher look at it. So this is essentially the unwrapped version of the last thing that worked, which was way back here. And so if we unwrap it, this is what it looks like. And there is one other way to handle things that get consumed that need to be retained. And I'm going to show you an undocumented command first, and then I'm going to show you a documented command, because the undocumented command makes it a little more obvious. And that command is multi-report. So the nice thing about multi-report is it allows you to make copies of the incoming events and process them multiple times. And in this case, what I'm going to do is I'm going to take the first copy and just preserve it. I'm going to do nothing to it at all, except encode it with a serial number where the first one has a 1, and the second one has a 2, and the third one has a 3, and so on. And then we're going to pass the second copy to our code, which consumes our data. And we're going to do the same kind of encoding as the first one so that we can join them back again. So we're going to have the original events. If we have 10 of them, we're still going to have 10 here, 10 original events. And we're going to have 10 answers that are returned underneath them. And we need to then merge them back together so we have our original events with the new details. And if I actually run this, it works. But I'm going to unwrap this and let you look what it looks like without it. So this, because I'd like you to see how this join works. This stats value star as star is really, really commonly used. I use it a lot. I didn't invent it. It's been around a long time. But what it does is it says, this guy has a serial, underscore fields are invisible, but he has a 1 and a 2. This guy's a 1 and a 2. And so for the 1 case, which is the first one and the third one, we're going to have a base of 2, a base EXP power of 1024, and a power of 10. And then for the second event, you're going to have first and third, and you're going to join them together, and then you're going to throw away this invisible field serial, and now we have what we needed. So now all that remains to be done is to wrap this one more time in a macro. But before we do that, let's look at the documented way of doing it, which is to use append pipe. So the difference with append pipe is that it automatically preserves the original events. It only lets you have one processing stanza, whereas multi-report will let you have as many as you like. And it will append the processing results to the original events. And this is probably safer, like I said, because it's a documented supported command. But it does exactly the same thing in exactly the same way. And what I would say about this solution in general is that while it does work, and while we are going to wrap it in a macro, it probably doesn't scale well. It's a great proof of concept. It's a great way to show you a bunch of cool strategies of stretching Splunk, but it probably won't work with, it'll probably work with 100 events. It'll probably work with 1,000 events. It'll probably work with 10,000 events, but probably not more than that. But the good news is, if it doesn't work, it's not going to hurt anything. So here's what it'll look like when we put this exact same code here inside of yet another macro. And we're going to call this one POW by names because we're passing in field names instead of numbers. Very straightforward. It's exactly the same. And now when we call it, we're done. So it works. It does exactly what we need it to do. I want to show you the arbitrary original events that it creates. It's just creating a base called 2, a base called 3, both to the power of 10. This is the original event. So we have 2 original events. We better have, and 2 fields. We should have at the end the 2 original events, but now 3 fields with this base EXP power with the value. And indeed, when this runs, it actually does exactly what we need. Here's our new field, and 1024 is to the 10, and 59049 is 3 to the 10. And if I was to change this to, something else, it works. Now, the last thing we're going to try, which is going to be a failure, but that's okay, is let's just see if we stick the numbers back in. In other words, if we pass values, we know that the POW by values failed when we pass in names. Does the POW by names fail when we pass in values? And while it doesn't give you an error, it doesn't work. So while this works, it needs special care to use, and you need to make sure you use the right macro. And remember, the purpose of this talk was not to give you 2 macros, a POW by names value or macro and a POW by values macro. That's not the point. I mean, if you ask me for the code for the macros, I'll give them to you, but that's not really the point. The point is all of the other concepts that were presented in this talk. Probably very few of them you would be able to find anywhere else, certainly not as densely packed as what we're doing here.
That really is the end of this talk. And I hope you all learned something. I'm sure you learned something. I hope it made sense. But you'll probably have to come back and watch this recording again later. It's a lot to take in one setting. But if you have questions, if it's not making sense, or if you take this and do something cool, please do get back in touch with me. Catch me on Slack, send me an email. Let me know what you're doing. Let me know how this benefited you. I've really had fun with this talk. I've presented it a couple of different times. This is the first time to a much broader audience. But I had fun with it. I hope you guys had fun with it too. And I hope it's profitable to you in your other Splunk adventures that you're doing. Thanks again for spending this time with me.